Alright, in the last video, which was very long, we talked about naming ionic compounds. There was one last type of ionic compound that I want to talk about very briefly when it comes to naming them, and these are hydrated ionic compounds. What makes them hydrated is pretty much what you would think from the name. It's that there are waters that are attached to the ionic compound. So we have a normal ionic compound, just like we've seen before. So example here would be magnesium sulfate. And it's not just that ionic compound that is present in the material that we're looking at. There are some water molecules that are kinda, sorta bonded to the magnesium sulfate. It's not quite the same as ionic bonds or covalent bonds. It's more of an association, but it's close enough that we still consider it part of the molecule. It's a hydrated molecule. So in this case, this is magnesium heptahydrate is what we would call this. And this one down here would be cobalt 2 chloride, and we need the 2 there because the cobalt is not in the first 2 columns, or aluminum. So cobalt 2 chloride hexahydrate. Essentially, the rules for these are you put the name of the ionic compound, and then you put hydrate with a prefix that indicates how many of the hydrates you have. Now, I don't have the prefixes listed here because we're going to see them on the next slide, but they are the same prefixes that we use for molecular compounds. I'm going to kind of skim over this at this point because, frankly, I'm not too worried about you knowing how to name hydrated ionic compounds. I'm not going to be asking you questions over these on the exam. There might be 1 or 2 of them on the homework. I don't remember actually off the top of my head if there are hydrates in the homework, but they're relatively rare and few between, so I'm not too worried about spending a lot of time on this, but I did still want to point it out to you because it is something that shows up every once in a while, these hydrated compounds. Alright, so moving on to the molecular compounds. So these are compounds that are covalently bonded together. So it's always going to be 2 different non-metals. That's what we're going to be looking at here. So when we're naming these, we can't name them the same way that we named ionic compounds, because with ionic compounds like the magnesium sulfate, for example, magnesium and sulfate only have one way that they can come together, because magnesium can only have a charge of +2, sulfate can only have a charge of -2. There's only one possible way that those can combine. With the nonmetals, on the other hand, they are much more flexible. There's multiple ways that 2 nonmetals can bond together. So for example here, if you were to tell someone that, oh, I have a molecule with nitrogen and oxygen, then if that person was a chemist, they might respond by saying, well, do you have NO, NO2, N2O, N2O3, N2O4, N2O5, and there's actually even more than that, but those are the more common ones. So which one? Because nitrogen and oxygen is not enough information to know which one you have, and all 5 or 6 of those there are going to have different properties. They're all going to behave differently. So it's not just enough to know what you have. You actually have to know how many of those atoms you have. So this is where the prefixes that I mentioned a minute ago are going to come into play. So we're going to be writing the names of these, and we're going to indicate how many of each of these things we have, how many of each of these elements we have present in our molecule. So first of all here, when we're writing out these formula, the element that comes first, since they're all just nonmetals, we can't have rules like we did before with the ionic compounds where we could just say the metal comes first. With these, we do need to specify which nonmetal is going to come first. And so the element that is farther to the left on the table is going to be to the left in the name, or in the formula. So farther on the left means it'll be farther to the left in the formula. If you have two things that are in the same column together, so for example oxygen and sulfur are in the same column in the periodic table, the one that's farther down on the table will come first. Alright, so we have our prefixes here. So this is our naming method for these molecular compounds. We're going to take the prefix for the first nonmetal, stick it at the beginning, attached to the name of that first element, which we're not going to mess with at all. And then we're going to have the second nonmetal. It's going to have its prefix as well. But the second element, we are going to mess with the base elemental name. We're going to replace the ending with "ide," just like we did with the ionic compounds. Now there is one exception to this rule, and that is for the first prefix here. So the first element always needs a prefix, with the exception of if you only have one of that first element. So a molecule you're very familiar with, CO2, that is carbon dioxide. It is not monocarbon dioxide. It is just carbon dioxide. If we only have one of the very first element, then we just leave the prefix off, and it is understood when you don't see a prefix, you are meant to understand that there is just one of that particular element. So for the rest of these prefixes, they follow the same overall. Well, let me rephrase that. Essentially, they're from the Greek, is where these prefixes come from, and they're the same as the shapes. So if you're familiar with pentagon, hexagon, heptagon, octagon, it's the same kind of idea there. So I'm not sure if tetragon, that's not a phrase that's normally used. It might be a technically correct phrase. Most people would just call it a four-sided shape, a square, instead of a tetragon. But anyway, the mono, di, tri, and tetra are a little bit different than what you would think of with shapes, but they are still pretty self-explanatory. Di being 2, tri being 3. Tetra is maybe one that is a little bit more difficult to work out. But then from that point forward, it does pretty much follow the same as the shapes. So penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. Now they do go on past that as well. So there's one for 11 and 12 and 13. But we're not going to worry about those because we're never going to have any that go that high. We probably won't even get up to deca at any point. But these are the first 10 prefixes here. So, already did that first one there on the previous page. The second one here, we have a single carbon and 4 chlorines. So, because we have only one of the first element, we are not going to have monocarbon. It is just carbon. The names of these will never start with mono. So it is just carbon, and then we have chlorines, so those are going to be chloride, and we have 4 of them, so tetra chloride, since tetra is the prefix for 4. Okay, so why don't you go ahead and try the rest of these here. So there's 6 more for you to work on. 3 of them you're going to write the name, 3 of them you're going to write the formula. Personally, I think writing the formulas is a lot easier than writing the names, but neither of them are terribly difficult. So go ahead and give those a shot, see if you can get the correct answers, and we'll come back in just a second and work them out together. So pause the video now. Alright, so with the first one here, this is our first example where we do actually need a prefix at the beginning because we have 2 sulfurs. So this is going to be di sulfur trioxide. Disulfur, 2 sulfurs, trioxide, 3 oxygens. Next one here we have xenon, and it is just xenon because there's only one of them. Tetra fluoride. 4 fluorine excuse me, 4 fluorines. Next one there, very similar actually. This is going to be silicon tetra chloride. For the formulas down below here, diphosphorus, 2 phosphoruses, tetraiodide, 4 iodines. Carbon monoxide, because there's no prefix given, it's understood that we have just the one carbon. Monoxide, single oxygen, so we have CO, and then carbon disulfide, CS2. Okay. Since the last video was so interminably long, I think we'll go ahead and make this one a little bit shorter, and we'll do the acids and bases in their own video here to wrap up the chapter. So I will see you over there in the next one.